This is a question about sequence, obviously, so you have to recall all the formulas in your brain immediately. And then we are talking about a metric sequence, so GS is not applied here. We are going to apply a metric sequence formulas. They say that the third term is 5, 6, 7, so the first equation, the third term is equal to 5, 6, 7. At the same time, the fourth t term is equal to 2, 3, 4. Then we just apply the formula here. A very important thing is to find out what is the first term and also what is the common difference. A and then plus 3 minus 1 time of the difference is equal to 5, 6, 7. That means A plus 2 time of common difference will give us this value. Similar reason, A plus 40 minus 1 time of D is 2, 3, 4. That means A plus 39 times of common difference will give you 2, 3, 4. To conclude these two equations, that means common difference D and also the first term A form a simultaneous equation. Then we can solve it. We find that both A appear in both equations, so we can just subtract them to get to make A minus A become 0. So I use below minus above. A plus 39D and then minus A plus 2D should equal to 2, 3, 4 minus 5, 6, 7. Don't forget the order. I try to use the bottom one minus the upper one. So right hand side, we follow the same order. A minus A becomes 0, so only one unknown is left, which is 37 times of D. We get negative 3, 3, 3, and if we divide both sides by 37, then we get 1 time of D, which is negative 9. So we already finished part A. But don't forget that among this calculation, we never describe what is A, what is D, so you should write clearly to answer the question. You know the common difference is negative 9. In part B, we are going to find the greatest value of k such that this gives you the condition. The required condition is the k term of sequence is positive. So the k term, we are going to apply Tn again. They say that the condition is k term is positive. Here mean always larger than 0. Some of you consider the equal case, but it's not the meaning of positive. We are talking about larger than 0. So you just consider the boundary is more difficult for you to analyze the question. So given the criteria is the k term is larger than 0, we try to evaluate these inequalities. Then we apply what we learned about inequalities. It's fine for us. We have A plus n minus 1 time of D is larger than 0. In this case, A plus n, that means k minus 1 times. Common difference, we already know is negative 9. So to solve this inequality in terms of k smaller or bigger than something, then we still need to get A first. So before our calculation, we try to get A first. Since we already know A plus 2D give you 5, 6, 7. D is negative 9. Therefore, A is 5, A is 5. After we get A equal to 5, A is 5, then this inequality only involving K as the only unknown. Then we can solve this inequality. 5, A is 5 minus 9 times of K plus 9 is larger than 0. Minus both sides by 9, 5, 9, 4. And then divide both sides by negative 9. Again, be very careful. When you divide both sides by negative value, then the sign, the direction will be changed. It will become k smaller than 66, which means the maximum k, it can't be exactly 66, so 1 less than 66 is 65. To ensure it fulfills this requirement, then the greatest value of k is 65. In part B, we take the k be the value found in B1. We are going to find the sum of first k term. Sum of first k term, so we just need to apply this information. We have all the information about A and D and also k, so it's really easy for us. That means we are finding the sum of first 65 terms. Number of terms divided by 2 and then 2 times of first term plus n minus 1 time of d. That means the first term plus the last term. N here means 65. A is 5, A is 5. N is 65. And D is equal to negative 9. The rest, you just need to use the calculator accurately. The final answer is 19305. Even though you make any mistake in finding A and D, just simply assign some values and then apply the formula here. It will give you 1 method mark.